This question, we were asked to compute this definite integral using a Riemann sum based on a right-hand approximation. Remember, to compute this definite integral, the integral from 0 to 4 of f of x dx would equal the limit as n goes to infinity of the sum of I equaling 1 to n of f of x delta x. So we need to set up this sum, f of xi delta xi. We need to set up this sum and then compute its limits. Now, I like to use this type of setup. We have n equals n equals little n, a equals 0 from our expression, b equals 4 again from our expression, f of x equals x squared minus 2. And now delta x equals b minus a over n, which equals 4 minus 0 over little n, which equals 4 little n. Now, xi star, because it's a right-hand approximation, it's going to be a plus I delta x, which equals, because a is 0, 0 plus I times 4 over n, which equals 4 over n I. Now, f of xi star is going to equal 4 over n I squared minus 2. So if we take the sum of I equaling 1 to n of f of xi star delta xi, this equals the sum of I equaling 1 to little n of 4 over n I squared minus 2 times 4 over n, which equals the sum of I going from 1 to n of 16 over n squared I squared times 4 over n minus 8 over n, which equals 64 over n cubed times the sum of I equaling 1 to n I squared minus 8 over n, the sum of I equaling 1 to n of 1, which equals 64 over n cubed times n plus n, n plus 1, 2n plus 1 over 6 minus 8 over n times n. Simplifying this a little bit gives us this equaling 32 over 32 n plus 1 times 2n plus 1 all over 3n squared minus 8. Now, that is our Riemann sum. So the sum of I equaling 1 to n of f of xi star delta xi, that is the Riemann sum with n rectangles. So now, applying the limit to both, limit as n approaches infinity to both sides gives the integral from 0 to 4 of x squared minus 2 dx equals the limit as n goes to infinity of 32 n plus 1, 2n plus 1 over 3n squared minus 8. Okay, to solve this, we're going to bring this up, and we're going to take the limit, and we're going to move over a little bit. The limit, this equals the limit as n goes to infinity of 30 or 64n squared plus 3n plus 32, or sorry, not 3n plus 96n all over 3n squared minus 8, which equals the limit as n goes to infinity of 64 over 3 plus 32 over n plus 32 over 3n squared minus 8. Knowing our limits is infinity is 64 over 3 plus 0 minus 24 over 3. We have 64 over 3 minus 24 over 3. The 8 becomes 24 over 3 equals 40 over 3. So that is what we computed using Riemann sums, 40 over 3 units squared. So now we'd like to, that is our Riemann sum using a right-hand approximation. In B5, we want to verify this. So we're going to verify this using the fundamental theorem of calculus 2. So the integral from 0 to 4 of x squared minus 2 dx equals x to the 3 over 3 minus 2x evaluated at x equals 0 to 4. So this equals 4 cubed over 3 minus 2 times 4 minus 0 cubed over 3 minus 2 times 0, which equals 64 over 3 minus 8 minus 0 minus 0, which equals 64 over 3 minus 24 over 3, which equals our 40 over 3. And we have our solution.